Hello, and welcome to this course that we here at Apis IP Solutions like to call SIP Advanced. My name is Martin, and I will be your teacher throughout this course. My background is in, well, first of all, lots of IP stuff, switching, routing, and then I worked for over a decade with VoIP, SIP, IMS, and Voice over LTE, both of which are totally founded in SIP. So it's really important stuff that you're going to learn today. This course is going to be comprised of different kinds of modules. We have the foldouts. Those are the papers that we're going to draw on together. I'm going to show you presentations, just PowerPoint slides and things that sort of complement the foldouts. There's also available to you a SIP message walkthrough where I just look through a SIP message to just essentially explain every detail of that one message, to show you a little bit about the format of a SIP message. And finally, we have 5 exercises, the material of which you've been given. So you have some Wireshark files, and you have some questions. And if you go to the exercise modules, there will be a little intro, and then I'll give you time to go through the exercises, and then I will sort of summarize the questions for that exercise. So it will be essentially a little film in which you pause in the middle, and then when you're done with the exercise, you will just hit play again, and then I will tell you all the answers. If you need to, you can download the software that we use, Wireshark, from wireshark.org. And if you need any hints or help with Wireshark, there's a Wireshark intro on our website and our YouTube channel. You have your foldouts ready, I hope. We're going to draw in these together. So you have that, and you have your pens and your ruler. But I will actually start off with the first section called SIP Review, in showing you a couple of PowerPoint slides, and then we'll go over to the foldout. So let's take a look at what VoIP really is. So VoIP, of course, stands for Voice over IP. It's very non-specific. It's just voice, and it has to be over IP. So really we have two sides like this. We have the Alice side and the Bob side. It's always going to be Alice and Bob. They're like the bread and butter of communications in the IT world. It's Alice over on the left side and Bob over on the right side. It's always Alice calling Bob. She probably has something for Bob. So Alice and Bob have their IP addresses. They've been given IP addresses in some way. We don't know how, really. It could have been DHCP, it could have been statically assigned to their computers or phones. If they're mobile phones, they could have been given out by the mobile networks. It really doesn't care, and that it doesn't matter. And that's the point. VoIP sort of starts off after having been given an IP address. So they both have IP addresses, and what they want to do is this. They want to sort of stretch a green line between them. This green line is media. This is IP packets with small snippets of voice. How much voice? Well, maybe 10 milliseconds, 20 milliseconds, 40 milliseconds. That's sort of the range we're talking about here for every IP packet. So that's what they want to do. And in order to do that, they need to exchange information. They need to find each other in some way in order to be able to send this green line or the packets in this green line to each other. So how do they do that? Well, they need to agree on, or rather convey to each other a small set of information. So what they have to work with is really the IP stack, right? We have the lower layers down here, which is the physical and Ethernet layers. We have IP with IP addresses. We have the transport layers, TCP, UDP, and then higher layer applications. The most important thing here is to be able to find each other, addressing. So in this layer right here in IP, well, there's a pretty important address in there. It's called the IP address, not very surprisingly. So they need to exchange each other's IP addresses or get to know the other person's IP address. That's not enough. This is enough to get right up to sort of the edge of this computer. That's where the IP address sort of sits. But then you need to hit one of the applications in this computer. So if there's a SIP phone running in this computer, then we need to address that particular SIP phone, that SIP software. And we do that with ports. Ports is how we address applications within an IP host. That's how, if you have two web browsers on your computer, you download a web page on one of them, it doesn't turn up in the other because they're using different ports. So they need to exchange port numbers with each other so that Alice can say to Bob, my SIP phone is running on this port, it's listening on this particular port. Ports are up in the transport layers. It's a little feel in TCP or UDP. Finally, they also need to agree on how to encode the information in here. What they're doing is talking to each other, analog sound, waves in air. That needs to be translated into ones and zeros in these IP packets. This is done with a codec. You may be familiar with codecs such as MP3. MP3 is an audio codec. It's not a very common codec for telephony, but it is very much an audio codec. It turns analog sound into ones and zeros. Popular codecs in the telephony world could be G711, G729, AMR, AMR wideband. So they need to sort of agree with each other which codec they're going to use, so that when Alice sends ones and zeros to Bob, Bob knows what to do with those ones and zeros. But this is pretty much it. This is what Alice and Bob need to exchange in order to be able to start sending media. If they could meet up in the woods and just sort of swap small pieces of paper with each other, and on those pieces of paper it only said, I'm Alice, this is my IP address, this is my port number, this is the codec I want to use, and Bob did the same thing, only it started with, hello, I'm Bob, they would be able to do this. That would be the signaling protocol, meeting up in the woods and exchanging small pieces of paper. It's not a very scalable signaling protocol. It doesn't really sort of offer a good foundation for global telephony. But logically, information-wise, it would work. That's all you need. The idea, in order to avoid meeting up in the woods, is to take the information on that piece of paper and store it somewhere. Let's say this server here, one.com. It's a server of an operator that stores IP address, port number, and codec for users. So let's say Alice stores her information there, and Bob stores his information there. That means when Alice wants to call Bob, she doesn't need to meet up with Bob in the woods. She can just ask one.com, where is Bob? And one.com says back, well, Bob is at 2222. That's his IP address. This is all good and well for the operator called one.com. You see the title here? It says one domain solution. It's not a one domain world. There are more than one operators in the world. If you're one.com, perfect in the one domain world. For all the other operators, not so good in the one domain world. We need to move to a multi-domain world. So Alice and Bob may be customers of different operators. Let's say Alice is a customer of the operator A.net and Bob is a customer of the operator B.net. So what they do is they sort of tag that along to their name. So Alice is now at A.net, Bob is at B.net. And when they register their information, they do it to their own respective domain, to their own operator. So Alice says, I'm at 1111, and Bob says, I'm at 2222, to his operator. Excuse me. Now, when Alice wants to call Bob, she just sends it to her sort of operator, which in turn finds Bob's operator. It can do that by means of DNS, because it's not a complete coincidence that A.net looks like sort of a URL or a web name or a domain name, and this looks sort of like a mail address, user@domain. That's because we're reusing a mechanism that is working very, very well in the internet world, which is DNS. So what we need is some kind of standardized protocol for this, because I haven't said what this red stuff is yet. It's just some kind of, hello, I want to call Bob, where is he? That kind of content should be in these red lines. But it could be different formats, and there have been a number of protocols for this. Here are a couple of examples. SIP, H.323 from ITU, the International Telecommunication Union, which is also a VoIP protocol, and it has been quite a popular VoIP protocol, in fact, but it's now being the world is being taken over by SIP. So the H.323 users is really a diminishing amount of people. What happened essentially was that SIP became the de facto standard for VoIP signaling. One argument for why that happened could be that the IMS that I talked about, which we'll mention at the end of this course, the big framework for classic telephony over SIP, they chose for classic telephony over IP, they chose SIP as signaling protocol. This was in the beginning of this millennium, and when they chose SIP, the rest of the world sort of saw, this is probably an important VoIP protocol. Maybe we should go with that. So let us now jump over to the foldout. If you could take out your foldout called SIP Review. So here we are at the SIP Review foldout. Let's break out our pens. I will put my ruler up there. And up here we have a sort of a small networky kind of thing. So if we start by sort of zooming in up there, I like to say that in SIP everything is either an endpoint or not an endpoint. And we have here Alice and we have Bob. They're endpoints. So an endpoint in SIP is called a user agent. So let us put that over here. This is a user agent, or a UA. So I'll just underline that and say this is a SIP endpoint, like this. Hope you can read my writing. So if this is an endpoint, so where are the non-endpoints? Well, you can sort of see them in here, right? So those are SIP routers, but they're not called SIP routers in SIP, they're called SIP proxies. So let's put SIP proxy and SIP proxy like this. Now, these things, this is where I jump around in the folder. This is also incidentally the view where I can play the hand of God and say, repent, repent, sinner. So, enough fun. Now, more fun. SIP. SIP proxies are, by their very nature, or acting as a SIP proxy, means taking in a SIP message like this and forwarding it. So obviously you can see that these SIP proxies now have the capability to forward something, because you see lines going in like this. And this is an endpoint. It doesn't have anywhere to forward something at all. I need to just make a point here that you can't sort of pick up a thing and say, this is a SIP proxy, it will always be a SIP proxy. Or this is a SIP user agent, it will always be a SIP user agent. Because it can act as a SIP proxy for one SIP message and as a user agent for another. So in this example, for instance, if Alice over here calls Bob, well, there will be some kind of message, an invite going like this, swish from left to right. If one of these proxies decide to sort of return an error message of some kind, I can't find Bob or something, then it will create a response. It will thereby, by its very nature, be the endpoint for that message. So it will act as a user agent if it creates a response. So in a way, you can say a user agent is an SIP endpoint, and it's an entity that creates a request or a response, whereas a proxy is an entity that forwards a request or a response. So whenever you create a request or a response, you're a user agent. Whenever you forward it, you're a proxy. Okay, so enough of that. Let me fade away so that I can continue drawing here. So let's put down here SIP proxy. SIP proxy. And the SIP proxy routes SIP messages. Routes SIP messages. All right. Excuse me. So we have then our endpoints here, our user agents. We have Alice and we have Bob. And as you saw in the presentation before, they have an IP address that they've been given before, and they have some kind of operator assigned name that they will use as essentially a phone number. So over here we have Alice, and her SIP address is SIP:alice@a.net. A.net. A because you sort of pronounce it as the letter A, and then we'll have B.net over here at Bob's. So Alice also has an IP address, so we'll give that to her. IP, she has 100.10.0.151. Over here on the right side, we have Bob, and Bob also has a SIP address. It's SIP:, Bob at b.net. And Bob has an IP address as well. IP 100.10.0.150. They have to have different addresses, otherwise we will have an IP conflict. All right, so fair enough. These addresses, the Bob at b.net and the Alice at a.net, they're called URIs, Uniform Resource Identifier. That's a difficult name to say, and most people know the acronym URI, but don't know what it means. So I will write it down here. This is a SIP URI. I'll just put a little arrow like this so that we know that that's what we mean. And whenever you hear URI, just exchange it in your head for address. This is a SIP address. SIP URI is a SIP address. Now, we said previously that you need to register with your domain, with your operator, right? So far we put in 2 SIP proxies, well, one in each domain, and a SIP proxy forwards messages. Whoever receives a registration, and with the registration will mean Bob saying, hello, I'm Bob, I'm at this IP address, needs to be sort of acting as a user agent. Needs to say, okay, got you, Bob, I will make a note of that IP address that you have right now. So in the standard, there has been created this thing called the registrar. So I'm going to put registrar in here, but it's good for you to note that a registrar, you will almost never see it as a separate physical thing. It will have a box right up here, but it's almost always built into a thing that is also a SIP proxy. So let's put SIP registrar, or it's all SIP, so I'll just put registrar in there. That's the thing that takes in registrations for the B.net domain, and we will also put a registrar in here like this for Alice's domain. All right. Actually, let's make a little note of what a registrar does, so we don't forget. So over here, I'll just put registrar. I will underline it like this, and I will put receives registrations. It's fairly straightforward. It has a good name, but let's just put it down anyway. So receives registrations like this. Okay. So what do you think it does with these registrations? Well, it needs to store it somewhere, right? So the way it stores it is in a kind of a database. I say kind of because it's not standardized how to do it. It's very, very likely to be a database. I mean, technically in the world we live in today, but it's not standardized how it stores it. It's just called a location service, and it's up here. Location service. And of course there's one for B.net as well. Location service. This is where the different operators would store the information about where Alice and Bob really are. Let us put in the lines for the registration now. So Alice sends her register to the registrar. So we'll just do this. This is a red line because this is SIP. And when Bob registers, he will send his registration to his registrar like this. The forwarding of this information up to the location service is not SIP. It's actually proprietary. So I will just do this. I will put a little line up here from the registrar to the location service. And I will just put prop like this. This is proprietary. I will do the same thing over here on Alice's side. Prop. Excellent. So now we got some SIP lines, and we got a proprietary line with which the registrar writes in the location service. Now, what's going to end up in the location service is, of course, Alice and Bob's addresses. So what do you say? Let's put that in. Alice has this IP address down there, so that's what's going to be recorded up here in the location service. So now the A.net domain knows that Alice is at 100.10.0.151. And of course, the corresponding information for Bob is in the location service over here in B.net. So Bob is at 100.10.0.150. So now we've seen the registration, and we have some red lines here for for registration. We should probably put in some lines for the actual calling each other, right? So over here, when Alice wants to call Bob, she will send things through her SIP proxy, right? So let's put the red line in here, and then there's a kind of a gray line that you can use to follow, and just put red in on top of that gray line. So now we are in the position where Alice has registered and Bob is registered, and she has sent her invite to the SIP proxy in her own domain. But her SIP proxy needs to find the SIP proxy of the B.net domain, right? How does it do that? Well, remember how I said we reuse technology that has worked very well on the internet? Well, up here we have the DNS. So I will put in lines from the A.net SIP proxy to the DNS and the B.net SIP proxy. This line that I draw now on the right side isn't going to be used for this call. That's in case there will be an outgoing call from the B.net domain later on. That's not completely unlikely. So using the DNS up here, Alice's SIP proxy will be able to find the SIP proxy of B.net. So now we can put in the red line here, and using the information in the location service, the SIP proxy in B.net will be able to talk to the location service in B.net in order to find the address that Bob has registered previously. So up here, Bob is registered as 100.10.0.150, which means the SIP proxy can now forward the message to Bob's phone down here, Bob's user agent. All right, so now that they have found each other, they have done the equivalent of meeting up in the woods and exchanging IP addresses and ports and codecs, now they can actually start sending media to each other. So I'm going to draw the green line now from Alice all the way over to Bob like this. This is the media. This is the line with the packets in which Alice's and Bob's voices are contained. We might want to just add a little bit of information about the location service, I suppose, because we wrote things about the user agent down here, and we have the SIP proxy, and we have the registrar. We also have the location service. So let's put some information in here about the location service. I will underline it like this. And I will put that it stores the IP address or FQDN, that's fully qualified domain name, of the subscriber. So it stores IP address or fully qualified domain name of a subscriber, like this. As you will see later on, it can actually store more things than that. It will, for instance, it can store the port number if you're not using the standard port of SIP. But we'll get back to that later on, as this is a SIP Advanced course. We haven't said so much about how the SIP is actually sent, sort of in the IP stack. We mentioned the IP stack a little bit in the PowerPoint. Up here, we actually have a little IP stack. We have the lower layers here. We have the IP. We have the transport layers, UDP, TCP, and then this sort of third addition that is sort of a newcomer. It is a couple of years old, but it's not every day we get a new protocol on this layer right here. So SCTP, Stream Control Transmission Protocol, is sort of a mix between TCP and UDP, if you will. It doesn't have anything to do with streaming movies or music. It's a lot like TCP actually. The streams in SCTP are essentially like TCP sessions or TCP connections. So what do you say? We can actually use this little stack up here and put in SIP and maybe even RTP that is used to carry the green stuff. So if we start off with SIP, SIP can actually be carried by all transport protocols. You see how this box is sort of lying on top of SCTP, TCP, and UDP. SCTP isn't very common, I'd say. TCP and UDP are quite common, both of them. I'd say there is a slight advantage for UDP, meaning that there are a little bit more implementations using UDP. But that's just from my experience. You can use both TCP and UDP, and it works fine. The actual RTP is sent here. RTP, Real-Time Transport Protocol. It's the little protocol that actually carries the sound, the audio of Alice and Bob. So in here we can put media. I use sound as an example here because it's such a good example to have a phone call, but it could be, if they have a video call, it could carry video as well, and we will actually see other things later on that can be carried in this protocol. Something that we will see later on that we're coming back to as well is something called SDP. SDP is a Session Description Protocol, and it's right up here, carried by SIP, sort of as an attachment, if you will. Now, we are coming back to SDP. It's kind of important. That's a little protocol that describes the green line. This green line right there. So it's kind of important, and we're coming back to it. I just said that SIP carries SDP sort of like an attachment. It's actually not just sort of as an attachment. SIP follows technically the exact same format as email and a few other protocols as well. It's very popular to steal and also good. So a SIP message is essentially technically a piece of email, and you will see this from the headers later on as well. And much like email can carry attachments, so can SIP carry attachments. You can send a SIP message and attach a JPEG or a PDF or an Excel file if you want to. It's not very common to do that, but you very much technically can. What is very, very popular to do is to send SDP, a little text file with a description of this green line as an attachment in a SIP message. So that's sort of in the way in which SDP is on top of SIP in this protocol stack. Continuing on, there are requests and responses in SIP. Everything in SIP is either a request or a response. And the requests are called methods. So here we see all the currently known methods in SIP. There are 14 of them. There may be new, added. Check in with a section on SIP extensions later on, but currently these are the SIP methods that we know of. And we don't see any ones on the horizon just right now. There's also a number over here. It says RFC and a number. RFC means request for comment, and that's the name of all the standards from the Internet Engineering Task Force, IETF, namely the guys who standardize SIP. They're also the guys who standardize IP and TCP and DNS and DHCP and HTTP and other very well-known protocols. So essentially what this is, it's just a reference to the standard that defines this particular method. So you will see that a lot of them begin here with 3261, and that is, you could call it the Bible of SIP if you want to. That is the core standard for SIP. If you want to read just one RFC on SIP, it should be 3261 because it's the one that is the basis for SIP. And then there are others just adding stuff. So we have here these 14 methods, and we're going to see use for all of these methods throughout this course. I'm not going to go through all of them right now, but you can use this as a reference list later on to just see that we've actually sort of managed to check off every one of them. And I promise we will check off each and every one of these methods in this course. So all of these are requests. Remember what I said? Everything is request, response. Everything is either a request or response. So if these are requests, then we have down here responses. Responses are special because they have numbers. Every response begins with a number, and they exist in 6 different families of numbers. The 100s all the way down to the 600s. And if we want to group these things together a little bit, we can see that the 100 series of responses here, it says provisional response. That's because it's not final. All the others are final. Provisional response means just, here's a response while we're waiting for the final response. So the 200s, 2XX, means everything that begins with the 2 is the final successful response. I'll just put that in. Final successful, like this. Whereas all the others, put a bracket like this, are final unsuccessful. Final unsuccessful, like this. You can even see that they are sort of in a ascending order of unsuccessfulness. In a way, it becomes worse and worse, is what I'm saying. We have the 200s, which are success. Then we have redirection. That's, I can't find Bob here, but I actually have another address. He has a forwarding address, so there is a little bit of hope. Then we have request failure, server failure, global failure, which sounds like the end of the world. It really isn't. We'll come back to the 600s later on in this course, but SIP actually makes use of the fact that this is an increasing level of failure. So if you have several response messages and you want to choose the best one, you just look at the number. If I have a 400 response and a 500 response to choose from, the best one is the 400 response. This could also be a good point in time to just note that this may not be the first time you've heard of 3-digit response codes, because you've probably surfed the web at some point in time and seen 3-digit response codes. If I ask this in a course, usually the first one that comes up is, come on, say it loud. I'm betting that you said 404 right now, because everyone has seen the 404 not found surfing the web. But there are others as well. We have some 400s for non-authentication, that you're not allowed to see something. The 500s, server internal failure, and other similar popular response codes can be seen on the web and also in SIP. Very much like the 200. 200 OK is essentially the only message in the successful family of responses. And it's the same that's used in HTTP and many other protocols. So again, stealing is good. We don't need to have any bad feelings about this. If we move a little bit further down here, we have the SIP message format. We will look at SIP messages in more concrete form later on. A SIP message format has essentially three parts. There's a first line, which has either one of these methods in it or a number, depending on if it's a request or a response. So this number here will be the status code, in fact. Then we have a number of headers, SIP headers. Some of them just stolen from emails, to and from and things like that. You can have any number of them in any order. In fact, it's all text-based, so it's human readable. And then body, and body means attachment, payload. That's where I would put the JPEG if I want to attach a JPEG picture to my SIP message, or the more likely attachment, the SDP, Session Description Protocol, that I mentioned earlier. This is the sort of basic format of a SIP message. Now, if we move over to the fold out and take our pens here again, there is down here we have sort of a flow graphy thing going on, and we can use this to actually make a flow graph for a call. In fact, the call that we saw up here, only now with arrows and real SIP messages. So if I take my black pen here, put my red away, this invite, I can zoom in a little bit more for you so it's easier to read. This invite is sent from Alice to Bob. That means the address that points it in the right direction will be bob@b.net. So here it says invite SIP Bob at b.net. The next thing that happens is a provisional response. Do you remember the provisional responses down here? They were sent sort of not as a final response, just to give some information while we're working on things. So the provisional response that's sent here is 100 trying. 100 trying means I got your message, you don't need to retransmit. That's all it means. We'll talk more about reliability later and retransmissions when we talk about the statefulness of SIP. But right now, just learn that trying means I got your message, don't retransmit. Incidentally, regarding these numbers, it says 100 trying, and I put this word in trying, but the fact is, the word here doesn't really mean anything. Well, you know what it means in English, but to the machines getting this, it doesn't mean anything. When Alice's user agent gets this 100 trying, it does not care about the trying. It only looks at the number. So when we have here response codes, the numbers are all that's important. In the standard, in the RFC, in 3261, the response codes are written, and they have numbers, and they have their suggested text. That doesn't mean that text has to be what's used. So I've seen all kinds of texts looking at real networks in the world. I've seen 100 giving a try, for instance. Or I could put in 100 I really don't want to try. And it would be the exact same thing. Or I'm not trying. The 100 means what it means. So it's the number that sort of matters here. So after this has happened, the SIP proxy here, you can note here, by the way, just so you see that, this line here means that this is the line of that SIP proxy. See? And over here, this is the line of Alice's user agent. We also have a line here for this SIP proxy, and this is the line of the location service. This is the registrar, and over here is Bob's user agent. So what will be done now is the SIP proxy on Alice's side will make a DNS lookup up here. So I will just put that in here. I'll just put a little blue dot here and make DNS lookup like this. Fine. Now it has done that so that it can forward it to Bob's domain, b.net. So taking my black pen here, and I'm forwarding the invite to bob@b.net. So SIP bob at b.net. Now we need to make sure that the receiving end has sort of got this as well, so that we don't need to retransmit. So once again, we have the 100 trying. 100 trying. If you wonder about the different arrows that we have here, the different heads of the arrows, in fact, you can see that they're different. And that's something that we try to do consistently. The filled in head is a request, and the head that looks like this is a response. So that you can see that. And sometimes we combine them, like down here we have sort of combined the request and the response to make things simpler. But if you only have one, this is supposed to be a request and this is a response. All right, so we have the trying. Now comes the point in time where Bob's SIP proxy wants to look in the location service. In order for that to yield any results, Bob has to have registered. So let's put that in, and you can note here that this is put in ahead in time of the Alice calling Bob. So this has to happen before in order for Bob's SIP proxy to be able to find Bob, of course. So there's a register, the SIP method register. The registrar will make a note of this in the location service. So we now know Bob is at 100.10.0.150. And the registrar will say back to Bob's phone, 200 OK. Again, it's only the numbers that matter. This is a 200 response. This makes it possible for Bob's SIP proxy to now ask the location service where Bob is. So I'll just put in here Bob ? Because remember, this is proprietary protocol. This is not SIP. When the SIP proxy looks in the location service, it doesn't have to be any protocol strictly at all. Very often the location service is built in to a node, a physical node that is both SIP proxy and registrar. So all of these three things is the same actual function in the network. Apparently it gets a response, so it now knows where Bob is. So it forwards the invite to Bob at, and Careful now. Up here it says bob@b.net. Bob@b.net. Now the SIP proxy has translated this. Using the location service, it has translated bob@b.net into the actual IP address of Bob. So right now, the SIP message, the top line of the SIP message will say invite bob at 100.10.0.150. All right. Now we're waiting for Bob to pick up. We need to tell Bob that the phone is ringing, though. Of course, that's this phone over here going ring ring, in order to make Alice's phone go doot doot. What's called the ringback tone, notifying Alice that Bob's phone is in fact ringing, is done with a provisional response called 180. 180 ringing, which will be sent back all the way like this. Ringing. 180 ringing. So when this 180 hits Alice's phone, that's when Alice's phone or her handset starts going doot, doot, or whatever ringback is configured in that phone. Eventually Bob picks up the phone. That will be with the creation of the final response to this invite. The final response is 200 OK. If he picks up, the successful response for invite is 200 OK. That means Bob picked up the phone. So this will be sent all the way back to Alice's phone over there. Now, I said previously that everything in SIP is request or response. And that's true. I'm building up to telling you why I just lied a little while ago. But that was not a lie. Everything is request or response. But I also said something that sounded like it's all pairing up a request in companionship with a response, that they're all sort of pairs. And that would have been a slight lie if I said it like that. A pedagogical lie, though, because I'm telling you now, but a slight lie. Because there's one exception. The exception to this is the request called ACK. You can see it up here in the top list of the method list. So ACK, it stands for acknowledge, is a request in SIP. It doesn't always feel like a request, because what's going to happen now is this arrow right here will carry an ACK, and it just means I got your 200 OK. This is sometimes called a three-way handshake and is used in SIP and lots of other protocol as well. TCP does a three-way handshake, meaning when we start something important, we have three messages going ping, pong, and then ping again. So in SIP, it's invite, 200 OK, and then I'm going to put ACK in here. So ACK is a request that does not trigger a response. That's how I'd like you to think of ACK, and that's how I think of ACK, and it's worked for me. Some people try to really argue, well, it's kind of a response. No, you're down a dead end if you go that path, because responses and requests are handled completely differently in SIP. They're routed differently. They follow different rules. Responses have numbers. ACK doesn't have a number. So ACK is the one request that does not require a response. That's the exception to that rule. So let us put in ACK here. The final message in the three-way handshake. Invite, 200 OK, ACK. That's what I sometimes like to call the holy trinity of SIP messages. Invite, final response, ACK. It doesn't need to be 200k. It could be some other final response. But you always need to acknowledge the final response with an ACK. Finally, we can have some media. Let's use green for hang on. We need to do this. Did you notice how ACK is sent end to end here? It's an acknowledgement end to end. The final shake in the three-way handshake is actually sent directly between Alice's and Bob's phones. So Alice sends to Bob through the proxies to find Bob. That's the purpose of all of this up here. Once they have found each other's IP addresses and everything, they can communicate directly. So they will do that with the ACK if not told otherwise. The basic behavior of SIP is to try to communicate as directly as possible. So it's quite possible to send SIP messages directly between Alice and Bob. So I will put a red line in parallel to the green line like this, just to show you that they can communicate directly like this. So now we are in the position where they can actually start sending media. So in this big fat arrow down here, I will put media. And this could, for instance, be audio or video. Using my green pen here, green for the media. So I have a green line up there, and I have my green media written in the big fat arrow down there. So they talk and talk and talk and talk and talk, and then finally one of them hangs up. This is done with the SIP method by. In this case, it's Bob who hangs up, so he's going to send bye to Alice, and she responds with 200. Okay, I got your bye. You don't need to retransmit. This is the basis of SIP. We see the simple three-way handshake to set up something. You only need these three messages. Invite, 200OK ACK. We have provisional messages here that it would still work if those were lost. You don't need the 180 ringing, really. It would make Alice's phone not go ring ring or toot toot, the ring back. But you would still be able to make it work. This up here is sometimes called the SIP trapezoid. Trapezoid is a funny word to say, and it's a geometric form that is shaped by two parallel lines, one down here and the little one up there, and then we have two sort of slanted lines like this. And it's used in books and in the specification. Then they say if you know the SIP trapezoid, you understand SIP. And by that they mean you use the top part of the trapezoid to find Bob. You go through a local proxy, a remote proxy, and then Bob, while you're using the base of the trapezoid to continue the communication, both signaling and media. All right. I put in a SIP URI up here, so I will conclude this by showing you a couple of PowerPoint slides quite briefly on the topic of addresses and what registration really looks like. So we see addresses here, and in SIP these are called URIs, Uniform Resource Identifier. But as I mentioned previously, just replace that with address anytime you see it. URI is an address. It's also used in something called a request URI. That's the address that's on top of every request, where it says invite Bob. That address is a URI. It's in the top of the request, and it's called the request URI. But you can also just think of it as the request address. So these are examples of SIP URIs. Notice how they all begin with SIP. That's an important clue that there's SIP URIs. If I just take that away, if I just do like this, these are not SIP URIs. By definition, they're not. They could be, the top one could be a mail address, for instance, but they're not SIP URIs because they don't begin with SIP. So this is what you would put on your business card, for instance. You wouldn't put your IP address because that can change. So we have some examples here. Request URI could look like this. Invite, then it says teistokvist@ipsolutions.se. That would be the request URI in that invite. Here's an options request. This is a method that we're going to talk about later on in the extensibility chapter of this course. And then a request address, a request URI, alice@10123. You also sometimes see the term address of record. Address of record means something that you put in essentially a phone book, something that doesn't change a lot. So your business card address would be a typical example of an address of record. So that would be paul@ipsolutions.se or isaac@ipsolutions.se. Very specifically, you shouldn't put IP addresses in your phone book because you may have a new IP address tomorrow. So SIP URIs can have different formats. Well, they can look differently. There's one format, and I will show it to you here. But it may take different forms. So, for instance, this is a SIP URI. It's just an IP address, really. I mean, when you think of it, what you use this address for is to sort of translate it in some way to an IP address that you can use and forward the invite to. So what if you just start off with an IP address? Well, that works as well. So this is a legal SIP URI. You can put URI parameters after a URI, and you use that by adding a little semicolon here. So this is a SIP URI, and we've added the URI parameter transport. There are a couple of different parameters defined. They do different things. We will see a couple of them later on. This is one that sort of indicates which transport protocol this we want the user of this address to use. So essentially, it's contact me on this address. Please send it over TCP. That's what this means. You can also put in sort of requests to populate SIP headers in a SIP URI. So this is a SIP URI, cecilia@finland.fi. Then there's a question mark right there. And then subject equals SIP course. Subject, well, that's a SIP header. As I mentioned previously, we just steal things here. So we've stolen things from email. Lots of things, in fact, to and from, which you will see, but also subject. So you can have the normal subject header that you see in email. You can have that in a SIP message as well. It's not very common to have implementations that make use of that header, but you very much can. So this is, if you want to mail me, use this address. Also put in a subject header and write the word SIP course in that header. So these are sort of ways to modify or add to a request URI, semicolon and question mark. And those are pretty much the only ways that you can sort of add things at the end of an address. So we will just see more examples here. ips.se, something that can be translated into an IP address. This is a domain name. And then it says method. This is the URI parameter. Method equals register. And then question mark, the to header equals taisto. This is code for @ips.se. So what this means is if you want to use this link, click here, send a register to this address, and put in a to header with this value in it. We have the URI parameter user, which you pretty much only see with the user equals phone. This is to indicate that the user part over here is a good old telephony number, a good old PSTN phone number from, essentially, you can say, from the circuit switched world. There are other ways to do this as well, and we'll come back to that in the final chapter, which has to do with interconnect between the new and the old, between packet switched and circuit switched. You may see, well, isn't this the same thing as up there? But there is a little S here, SIPs. So this means secure SIP. Just like you have HTTP and HTTPS, this means running SIP over the encryption protocols SSL or TLS. This is legal and possible. It is currently very rare to see that used at all, but you will see it a lot mentioned in books and specifications. So just, you know, this exists. It's not a typo if you see SIPs somewhere. And finally, to conclude this slide, we have the complete format of all SIP URIs. We have the user, but also password. Okay. We have the host, that's the domain, but also port. So there's a colon there. Colon between password and user, colon between host and port. And then URI parameters and headers. That's the total format of a SIP URI. If we see the use of this, we can look at registration. So here we have the registration of someone at this address to the SIP registrar over there. This is the registration of Bob. You can see how this is from bob at lab2.zip. So we see some things here. First of all, we see our first SIP message now. We have a request line up here. It has the method register and the request URI lab2.zip. Then we have a couple of headers: via, from, to, max forwards, call ID, CSEC contact, and expires and contact length. There's no payload, there's no attachment to this SIP message. So this register is sent to the SIP registrar. The registrar sends a response back saying 200 OK, you're now registered. This contact address is where you're now registered, bob at 10123. That's what Bob put in contact here as well, bob at 10123. You may note that there's an expiration time. It says expires 7200. That's counted in seconds, so that means 2 hours. That means this registration will be terminated unless Bob re-registers within 2 hours, which normally means he would register after like 1 hour or 1.5, something like that. You don't wait for the last millisecond. And finally, if expires is 0, then that means the user is deregistered. So there's actually a very, very tiny difference between registration and deregistration. It's only the value of this expires. This is a function that's being used in other methods as well, as we will see later on. The expires being set to 0, meaning negating something, meaning we're shutting something down now. And in this case, we're shutting the registration down by setting expires to 0. All right, this concludes the first lesson. We're going to continue on, but right now we can take our SIP review and take it away and reveal the message forwarding foldout, which we will continue with in the next lesson. See you then.